Hi there. In this video, I'm going to demonstrate how to extract data from a very large database table, presumably with billions of rows, in parallel, create files in S3 bucket, and then load these files into the Snowflake, again in parallel. So, for the video, I have selected audit trail table. So this specific table is not that large, but it can be billions of rows. The same technique would be used for a larger table. So the idea is that you kind of partition the table based on a value in certain column. And when you do so, you create intervals with the start and end value of this column. And then you use intervals to drive the source query, which will be extracting data. But because you're going to be having multiple of these intervals, you then will be able to configure a flow to run extract for each of these intervals in parallel. So audit trail table has a start date column, which is timestamp, and we are going to use this column as sort of like partition column. So let's take a look at the data in this column. So I'm going to do minimum and maximum start date from audit trail. As you can see, the data starts in October 2022, and the max value is January 2023. So roughly three and a half months. Now, I'm going to use this knowledge to create a query which will partition the table. So I already have it. I'm going to run it and I'm going to explain. So this query creates a time series with a start and end date. The size of the interval of the series is 1 month. And it's totally up to you how you're going to split your data. So it can be 1 month, it can be a quarter, it can be 1 day, or it can be a year, or any other interval. Really depends on the size of the data set and the best technique that you can use to split it. So for this video, I'm splitting table in 4 chunks, starting in October and ending in next month after December, in January, in February. So I'm also adding a virtual column interval name just to name intervals differently. And now I'm going to use this column later on to kind of name files, add a suffix to the name of the file created by the flow. So the actual query really depends on your A, source database, B, column selection. So whatever columns or column you are using to partition the table, it's totally up to you. Also, the sizes of interval, as we discussed, is also up to you. So that's the driving query for splitting table in multiple chunks. So with that, we're going to switch back to flows. Okay. And we are going to create a brand new flow. So the flow extracts data from the source, which is audit trail table, and creates files. So I'm going to select database to file, flow type. I'm going to name it extract. I'm going to assign tag demo, which really doesn't matter. Then the database is a Postgres database. The table is audit trail. Okay. The destination connection is going to be S3 stage in S3. So the format is going to be CSV, and the table, the file name is going to be audit trail. Then we're going to add a suffix. Remember this column interval name that we added to the query. So here we go. So the flow will extract data from audit trail table. We're going to add some query in just a few seconds. It's going to create CSV files in S3 bucket, and it's going to name files using audit trail as a prefix underscore, and then it will dynamically add interval name to the file name. So now let's write a query. Under source query, I'm going to type in select star from audit trail where. Now this is where fun begins. So we're going to use the start column as a predicate, start date. And now we're going to use an interval. So it's going to be more than or equal to start date in the interval and less than end date. So I hope it's self-explanatory. Sorry, mistake. But I will explain this again. So in ETL works, source query can include tokens. Tokens are strings enclosed in curly brackets. So the values of the tokens are substituted at runtime. And there are various techniques, and one of the techniques allows system to set token values, then get the query and replace tokens on token values at runtime. Okay, very simple query. Now we're going to enable one more parameter, create new database connection for the source. So we are going to be running this in parallel for each chunk. We don't want to use the same database connection for each of these chunks. So some of the drivers or some of the databases are known to run slower when you are using the same connection for selecting data from the same table. So we're going to create a brand new connection for each of these parallel threads, extracting data from each of these chunks. So that's the bulk of the flow. I'm going to save it under demo tag. And I'm going to create another flow. So this is where it all kind of getting put together. So I've used so-called nested flow. So nested flow can execute other flows. We're going to add, I'm going to assign tag demo. I'm going to add the extract flow that we just created a few seconds ago as a step. So there is going to be only one step. But this step is going to be actually executed in a loop, right? So, and there are several loop types in ETL works, and this one is called SQL loop. So what SQL loop does, it executes a loop script, and for each of the records returned by executing this script, a SQL script, it will execute the flow. Now, if we will not do anything, the flows will be executed sequentially, just like in any loop, step by step. But in ETL works, you can actually say, hey, run this in parallel by providing a number of loop threads. So this is kind of threshold. So if you expect that there is going to be hundreds or even thousands of this, you can put hundreds or thousands. But in our case, it's relatively small, so we're going to use 10 as a threshold. And also, threads are not free. So remember, when you run threads, stuff in parallel threads, more memory is consumed and all of this. So you want to limit this, make this reasonable in number. So if you are going to have, I don't know, 1,000 chunks, having 100 threads would make it run faster than having 1,000 threads in most environments. So again, it's up to you how many threads you want to use. I usually take the number of chunks, set it to max, and then use some heuristics to figure out how many threads you actually want to have. So in this case, 10 is fine. So remember this query with interval name and start and end dates. So it's going to run on audit trail table, split it in chunks by just generating time series. It doesn't go through entire table. So it's going to run it. If table has an index on start date, the execution time will be in milliseconds. So the hardest part is to calculate min and max, and then the Postgres does the magic and generates time series. So we already ran it. We got some data. We got time series. So same query as we used before. So this case is going to be running in parallel. This is it. So now I'm going to run this query. And it runs in parallel. So you can see that there are different parallel threads. And just a few seconds it will finish. So in 8 seconds it extracted about 200,000 rows. So it's not a measurement stick here. So you can have performance much better or worse. It really depends on the size of your table and stuff like this. But the point is that each of these chunks was executed in parallel threads. So there were 4 chunks. So 4 threads were running at the same time in parallel, extracting data from a single table, creating multiple tables based on time series. So now let's take a look at the data. I expect that there will be files here, and there are, of course, files. One file for each interval. The interval has a name, and that's the name of the interval, and there is a data in each of these files. So we can query and see there is a data. Okay, so super easy. It took me about 2 minutes to create this flow. The hardest part was to actually come up with a query. And I want to be honest, so I used ChatGTP to generate this query. I don't remember syntax of Postgres that much, so I asked ChatGTP to generate me time series for min and max values based on a timestamp column, and it did, and it worked for the first time. So great tool. Use it to your discretion. All right, so that's the first part, right? So we created files in parallel for a large table in S3 bucket. Now let's load these files in parallel into the Snowflake. There are various techniques. I'm going to switch back to flows, but the fastest by far is to use a bulk load. So I'm going to select a Snowflake bulk load flow type. I'm going to name it bulk load, and I'm going to assign demo tag. Now, our source is going to be obviously S3 stage. Okay, our format is CSV. Now we have 4 files here and S3 bucket. So instead of entering files one by one, creating 4 transformations, we're going to use wildcard processing. So we're going to load all files which match this wildcard, audit trail underscore star CSV. We're going to load stuff in Snowflake, and we're going to load this in a table called audit trail. The table does not exist, so it's actually going to be creating this table on the fly. Okay, and now we're going to enable 2 more options. So it's already, it will already do the trick. So this flow will already load these files in parallel, extremely performant and extremely efficient. But we're going to make it even better. Well, we will add log each executed SQL statement. We're going to enable purge files if success. So we don't need this. Once files are loaded, we don't need them anymore. But we're also going to enable direct load and use copy into with a wildcard pattern. So Snowflake copy into command when wildcard pattern is provided is extremely efficient in loading multiple files in parallel threads. Okay, so if it's just how it works. There is nothing else for us to do, we're just going to enable direct load, use copy inter with a wildcard pattern, and we will let the Snowflake do the trick. So I'm going to execute this flow on existing files. So I added some extra login so you can see what exactly has been executed. So the flow finished in about 8 seconds again. And if you look at the log, it loaded files by executing a single copy into command with a wildcard template, which looks like this. The template was generated automatically for you. The format is CSV and all of this. And it also created a table on the fly because table did not exist. So it generated and executed this SQL statement. Okay. And now if we will look at data in Snowflake, we're going to see this table with all the data. Here we go. So this is it. To reiterate really quick, in ETL works, it is possible to extract data from a single large table in parallel using drive-in query, which splits the table in chunks. The nature or actual syntax of the query depend on you. You can be splitting data based on timestamp columns or primary keys. It's up to you. The size of the chunk is also up to you. So for this demo, I was using 1 month, but you can have 1 year, 1 day, or quarter, or I don't know, week. Really up to you. Okay. We are using an ability of ETLWorks to execute multiple stuff in parallel using loop, database loop. The drive-in query creates chunks, and then it executes query in parallel threads. So we're also creating a unique database connection for each of these threads to make this faster. It's not required. It's just it's extra option which you can enable and squeeze a little bit of more milliseconds from the system. Okay. And in terms of loading data, once files are created in S3 bucket, we were using bulk load flow type, which does not transform data at all. Just takes raw data in S3 bucket in a CSV format and loads this data into the table in Snowflake using dynamically generated copy into command with a with a regex template. Okay. Thank you.